Now we'll discussing about sequence and series, its previous exam questions. Before going to start sequence series, you have to learn few statements. That is, one of them is comparison test statements and D'Alembert's ratio test, Cauchy's nth root test, Cauchy's integral test, and next one is Rabi's test. Next one is logarithmic test. And also learn Leibniz test. Next one is you have to use frequently P series. That is sigma 1 by n power P is convergent if P greater than 1 and divergent if P less than or equal to 1. We are using frequently in this test. This is known as P series or auxiliary series. And also remember few formulae. Limit n tends to infinite 1 plus lambda by n whole power n is equal to e power lambda. Limit n tends to infinite n power 1 by n is equal to 1. Limit n tends to infinite r power n is equal to 0 if 0 lies if r lies between 0 and 1. And also remember that expansions of log 1 plus x, which is x minus x square by 2 plus x cube by 3 minus so on. 1 plus x whole power n is equal to 1 plus nx plus n into n minus 1 by 2 factorial into x square plus n into n minus 1 into n minus 2 by 3 factorial into x cube plus so on. Here n is a rational number and x is a real number in such way that mod x less than 1. We have to remember these formulas first. First read and understand those statements. Now we will discuss about its previous examination questions. Test for the convergence of the series sigma cube root n cube plus 1 minus n. Let un is equal to cube root n cube plus 1 minus n. Now n cube plus 1 whole power 1 by 3 minus n. So take n cube common. N cube of 1 plus 1 by n cube whole power 1 by 3. So 1 by 3 is applied for both the terms. That is n into 1 plus 1 by n cube whole power 1 by 3 minus n. Now expand 1 plus x whole power n form. Here treat x as 1 by n cube and n as 1 by 3. So by using this formula 1 plus nx plus n into n minus 1 by 2 factorial into x square plus so on. Okay. Now n take common for both the terms. Then what happened? When you take n common for both the terms, 1 minus n are got cancelled. Okay. So remaining terms are like this. Let Vn is equal to 1 by n square. Okay. Now calculate limit un by Vn as n tends to infinite. So here un is this, by Vn is 1 by n square. So 1 by n square, 1 by n square got cancelled. We have only 1 by 3. And the remaining we have n in the denominator. So as n tends to infinite, these are terms 0. So what happened? Only we have 1 by 3. So the limit of un by Vn as n tends to infinity is 1 by 3, which is not equal to 0. By P series, sigma Vn is equal to sigma 1 by n square is convergent since P is equal to 2, which is greater than 1. In P series says sigma 1 by n power P is converges if P greater than 1 and diverges if P less than or equal to 1. So by comparison test, sigma un is also convergent, because when sigma vn is convergent, sigma un is convergent. When sigma vn is divergent, sigma un is divergent. Next, test for the convergence of this series. Sigma n is equal to 1 to infinite 1 by root n plus 1 plus root n. Now take nth term of this series is un as 1 by root n plus 1 plus root n. Okay. Now root n plus 1, so that n take common for these two terms. Then we have n into 1 plus 1 by n plus root n. And then supply root for both the terms, root n into root 1 plus 1 by n. And then root n take common. Root n of 1 root 1 plus 1 by n plus 1. So here we choose Vn as 1 by n power of. Okay. After choosing Vn, find out limit un by Vn as n tends to infinite. That is 1 by n power of into root 1 plus 1 by n plus 1 by 1 by n power. N power of got cancelled. It remains 1 by root 1 plus 1 by n plus 1. As n tends to infinite, 1 by n tends to 0, 1 by root 1 plus 0 plus 1 is equal to 1 by 2, which is not equal to 0. By P series, sigma Vn is sigma 1 by n power of is divergent since P is equal to half, which is less than 1. When the value of P less than or equal to 1, divergent. When P greater than 1, that is convergent. So here half is certainly less than 1, so it is divergent. By comparison test, sigma un is also divergent. So problem 2 is over. Now test for the convergence of this series, sigma 4 into 7 into so on 3n plus 1 by 1 into 2 into 3 into so on n. Now take nth term of this series, which is un is equal to 4 into 7 into so on 3n plus 1 by 1 into 2 into 3 into so on n. Now apply D'Alembert's ratio test. Then what happened? Limit un plus 1 by un as n tends to infinite is equal to un plus 1, that is 4 into 7 into so on 3n plus 1 into n plus 1th term. So 3 into n plus 1 plus 1 by 1, 2, 3 so on n is nth term. We require n plus 1th term. So additional term is n plus 1. After n we have n plus 1. And by un is same. Now take the reciprocal. What happened? 4, 7, 3n plus 1, 4, 7, 3n plus 1 got cancelled. We have 3 into n plus 1 plus 1, that is 3n plus 3 plus 1, 3n plus 4 by n plus 1. Remaining terms got cancelled. 4, 7, 3, 7, 3n plus 1, 4, 7, 3n plus 1 got cancelled. And also 1, 2, 3 so on n, 1, 2, 3 so on n got cancelled. Those are all in product. So remaining we have 3n plus 4 by n plus 1. Now n take common for both numerator and denominator. Then n is cancelled for both numerator and denominator. We have this. Then as n tends to infinite, 1 by n tends to 0. 3 plus 0 by 1 plus 0, which is 3, it is certainly greater than 1. By D'Alembert's ratio test, the given series is divergent. Now, test for the convergence of the series x plus 2 square x square by 2 factorial, 3 cube x cube by 3 factorial plus so on. First of all, to test the convergence, you have to find nth term of the series. That is our first motto. That means you take un as n power n x power n by n factor. So when you take n for 1, what happened? 1 power 1 is 1 and x power 1 is x by 1 factor, which is first term. And n for 2, 2 square x power 2 by 2 factor, same. When you take 3, what happened? 3 power 3 x cube by 3 factor. So it is same. So nth term of the series is n power n into x power n by n factor. If it is not given, you have to write. Then apply D'Alembert's ratio test. To apply D'Alembert's ratio test, you have to calculate limit un plus 1 by un as n tends to infinite. So limit n tends to infinite un plus 1, that means we have nth term. You replace n for n plus 1. Then you can get n plus 1th term by un. Un is same. And take the reciprocal, then simplify. N plus 1 power n into n plus 1, x power n into x, n plus 1 factorial can be written as n plus 1 into n factorial, n power n into x power n. Then simplify this. What happened? We have n plus 1 power n by n power n into x. So n plus 1 power n by n power n can be written as n plus 1 by n whole power n. N by n is 1 by plus 1 by n whole power n. Because a power m by b power m can be written as a by b whole power m. Then what happened? Limit n tends to infinite, 1 plus 1 by n whole power n is e. By D'Alembert's ratio test, sigma un is convergent if the given value, if the limit value is less than 1. Our limit value is xe less than 1. That is x less than 1 by e. And divergent if xe greater than 1. That is x greater than 1 by e. And test fail if xe is equal to 1. That is x equal to 1 by e. Now check to convergence about x equal to 1 by e. So if x equal to 1 by e, you have to check what happened. If x equal to 1 by e, then un plus 1 by un is 1 plus 1 by n whole power n by e. Here you observed that un plus 1 by un involved e term. If un plus 1 by un involved e terms, when the D'Alembert's ratio test fails, then use logarithmic test. If un plus 1 by un is not involved e terms, then use Rabi's test. You have to remember that. Here e is involved. So we have to apply logarithmic test. We know that logarithmic test, limit n log of un by un plus 1 is L if the value of L is greater than 1 converges, less than 1 diverges. Okay, that is a logarithm test. Now find out the limit. N times log un by un plus 1 we found in the above. Un plus 1 by un is 1 plus 1 by n whole power n by e. Now what happened un by un plus, take the reciprocal. E by 1 plus 1 by n whole power n. Log a by b can be written as log a minus log b. Did you understand what I said? Here log e is 1 minus log 1 plus 1 by n whole power n. Log m power n is n log m. Then limit n tends to infinite n into 1 minus n log 1 plus 1 by n. That is log 1 plus x. Expand log 1 plus x. The formula about log 1 plus x is x minus x square by 2 plus x cube by 3 minus so on. Supply n for these terms. That is 1 minus n into 1 by n is 1 and n into 1 by 2 n square is 1 by 2n and n into 1 by 3n cube is 1 by 3n square. 1 minus 1 got cancelled. We have 1 by 2n minus 1 by 3n square plus so on. When you supply n for both the terms, then what happened? 1 by 2 minus 1 by 3n plus so on. As n tends to infinite, 1 by n tends to 0. So we have only 1 by 10. We have only 1 by 2. And remaining terms are 0 as n tends to infinite. So we got 1 by 2. When the limit value is greater than 1 convergent, less than 1 divergent. Greater than 1 convergent, less than 1 divergent. Here limit value is less than 1. So the series is divergent if x equal to 1 by e. Therefore, the given series converges if x less than 1 by e and diverges if x greater than or equal to 1 by e. Because diverges if x greater than 1 by e, x equal to 1 by e also diverges. So that we are writing the given series converges if x less than 1 by e and diverges if x greater than or equal to 1 by e.